where we are right now, if you guys, well, let's start here. As you guys were writing notes this morning, anyone just joining us, the kids were writing down these notes, getting ready for today. If you guys remember this two Fridays ago when I was gone, you did not turn in your notes or your homework spirals. I am going to grade them, just not right now. Because if I do it right now, you're going to lose your notes, you're going to lose your homework spiral. I might do like a quick tomorrow as you guys are doing test corrections, walk around and check your notes. That's fast. You just have to show me your table of contents. I tell you a random page to turn to. It's there. You get 100%. So have your notes ready tomorrow. Homework spirals take a little more time. So, Kyle, do you remember what question you asked me that I told you to wait on?
Test.
Are we going to have another test?
Are you
going to have another test? No. Are you going to have a quest? Yes. And it's going to be next, now listen carefully, Wednesday. It's going to be next Wednesday. We're going to cover section 3.5, 3.6, 3.7, and 3.8. Okay? So 4 sections. Now, next Wednesday, so we just have Thursday and Friday before finals? Yes. But next Wednesday, it will be an experience not to miss. Meaning, it is meant to help your grade and not to hurt it. Does that make sense?
Yes.
Okay. So, for those of you guys that are like stressed out, as long as you do your homework, as long as you have your notes taken, and as long as you are as caught up as possible by next Wednesday, it should be a good experience, not a bad one. Does that make sense? Okay. Those of you in honors, you might remember what happened last year, winter break, right before the finals week, and how the test was taken. It will be very similar. Anybody remember?
I don't know.
No one remembers? Bummer. Anyway, it's okay. I can give some more hints as it comes along. But long story short, it's meant to help your grade. Guys, listen carefully. Your Google Classroom is all set up, ready to go. We cannot fudge on any deadlines. Meaning, we have to go fast. But in going fast, it's so we can get a quest next Wednesday that will help your grade, not hurt it. And so that you have all the content that you need to end first semester for the final. Now, you also have a forever final next Friday. Now, some of you are starting to freak out, except it's 25 points in your final exam category. There's the final exam worth 100 points, and there's 25 points. People that want to do rough math, that makes it about 1/5 of your final exam and strict memorization. Meaning, no tricky AP questions, no tricky multiple choice, right or wrong, because it's a Scantron, so the final exam is right or wrong or partial credit. No huge long answers that you get stuck on and you don't get to do any of it and you miss tons of points. Okay? Strict memorization. Next Friday, you have to have forever cards numbers 1 through, I think, 30 is what it is.
Nice.
That's so many.
But to help you for that, every day for an opener, I'm going to have you turn to the back of your homework spiral, starting not tomorrow doing test corrections, but starting Wednesday. I'm going to ask you a random forever card to see if you remember. And we're going to do that every single day, and maybe a couple times a day as we study. Okay? So do we have a lot coming? Yes.
No.
But time out and pause. What do you notice about the board and the things that you wrote down at the beginning of today? For this section that technically was supposed to be before the last test, but because of the fire days and everything else, I tabled it and said, let's just wait and come back to it. So instead of being in Chapter 3A, Analysis of Function Behavior, it's in Chapter 3B, Further Applications of Derivatives. What do you notice about everything up here?
It's all review from the last 4 sections.
It's review. What is all of this review of? Pre-Cal, everything before Cal. What is this? And kind of summer packet, right? And then what is everything here? Chapter 3A. Increasing, decreasing, concavity, relative extrema, points of inflection, Dirichlet relative, critical numbers, pips. Anyway, it's all review. So the nice thing is, today and tomorrow is all review applied. Now, hold on, listen carefully. If I were to go to your Google Classroom right now and pull it up, in there is, oh no, the derivatives are attached. Because remember, get those derivatives simplified. Why? Because it was supposed to be last test. And what was the point of Chapter 3A? How do we analyze a function and what it's doing from first and second derivatives? Does that make sense?
Yeah.
But you had to find the first and second derivatives, true? Now on the test, did I give you every now and then a first or second derivative?
Yeah.
Yes, at least on a couple questions. But if you already have the derivative, you just get to use it. But for the majority of the test, what did you have to do? Get those derivatives simplified, right? Find them, simplify them, use them. True? Okay. But since we're past Chapter 3A, what do you notice that's right here? given, simplified, first and second derivative. So on the quest next Wednesday, for this section, section 3.5, guess what I'm going to give you? Derivatives simplified. Now on the final, are they all going to be given to you and simplified? No. But for next Wednesday, yes. Meaning, how do you approach this homework that's due on Wednesday? Could you be practicing your deriving skills? Yes. And would that be valid for the final? Yes. But do you have to if you need to cut corners?
No.
No. Now listen carefully. Did you hear what I just said? Could you be finding derivatives and simplifying them to practice for the final? Yes. Just like you did in homeworks 19 and 20. But could you be cutting corners, going to my answer key, taking the two derivatives, and using them in preparation for next Wednesday? Yes. The choice is yours. I leave it up to you. I'll post a comment on your homework. So if you need to save time the next 2 days, this is the way to do it. Grab my derivatives and use them just like we're doing in class. Sound good? Okay. Making sure we're all on the same page. So what we're going to do today is, as quickly as possible, go through and give ourselves basically quick little cheats, quick little hints, quick little reminders of what these things are and how we're supposed to put them all together. Section 3.5 is a grand old, huge summary of all of Chapter 3A, and technically all of the before calculus with function, behavior, and analysis, and all of the after calculus, putting it all together. So most people will remember this, most of my calc kids, as the 15. The 15 identifies. I put 14 because there are, have you guys counted yet? 2, 4, 6, 8, 10, 12, 14. So why am I going to come back here and make it 15? Because what is the very, very, very last step? Now, graph.
Thanks, John, so much.
In pre-cal, I told you, if you knew calculus, we could do a lot more. Well, now it's time for us to do a lot more and to get the perfect graph of any function, well, any function that we can analyze by hand at least, with these 15 steps or 15 identifies. So here we go. Really 14 identifies, and we put it all together. And a quick heads up for you guys, I am not making this a forever card. The AP doesn't say, like, list the 15 steps. But it puts it all together, and if I were to give this to you next Wednesday as a problem, which I will list it all. You just have to find it. Does that make sense?
Yeah.
Cool. So let's go ahead and do some reminders for ourselves and solve for each of these and try to figure out the function graph of this. If I were to ask you right now, who is this guy and what does he look like? Exactly. He's not a basic graph, right? Like maybe I could try to divide and play with it, and maybe I could do some illegal killing of kittens and think that he's something like this, but I don't know. So, how do we know who he is? Let's some reminders. X-intercept, what do? We set
A equals 0.
Y equal to 0. And we solve for x. So let's do it. If we set y equal to 0 and solve for x, 2x over x squared minus 1 with a pitchfork, have you guys realized where to always look for zeros in fractions? And the top or the bottom? Top. But if you need to do some math, you could multiply both sides by this guy. Don't forget those parentheses. And you get 0 equals 2x, which will occur at x equals 0. We have our x-intercept. Y-intercept. What do we set equal to 0 instead? The x. So then let's do that. Let's go ahead and plug in y of 0 or f of 0. We get 2 times 0 all over, hey, that's 0 over negative 1. Isn't that just 0? Huh. I guess that's not fun, but we have a point that we can graph now. Vertical asymptote. Where do we look for those? Why am I putting non-removable?
Because the holes are removable.
Holes are removable. They both show up in denominators. We got to be careful, but non-removable discontinuities. Question. Do I have some domain problems up here?
Yeah.
What can x not equal? Plus or minus 1. Are any of them removable?
No.
No, because if I was to write this in its factored form, wouldn't I have 2x over x plus 1, x minus 1? Can either of these reduce with x or 2? No. So therefore, they're both non-removable. So where are my vertical asymptotes? At x equals both of them. Now, you can put a not equal to if you're trying to state the domain. You can also say there's a vertical asymptote at these x's. I'll take it either way. I understand both. I would probably put vertical asymptote at x equals. That's technically the best way of saying it. But if you're trying to show me the domain, that's okay. Holes. Why am I going to say none for this one? none of them reduce, right? So those would be the removable, the reducible, I know it's awkward, but it works, discontinuities, but we have none that reduced away. Discontinuities, hold on, discontinuities. Definition of continuous, hey, forever final next Friday. What are the three things that have to be true for a function to be continuous? Number one, f of c is defined, aka f exists at c. Number two, the limit. Yeah, that has something to do with it. The limit as x approaches c of f of x exists. So the point exists, the limit exists, the approach, the at, right, and the approach. And then number three, they need to agree. So f of c exists, the limit as x approaches c of f of x exists, and then f of c equals the limit as x approaches c of f of x. Now there is the other forever card that says, if a function is differentiable, it must be continuous. If a function is continuous, it may be differentiable. Watch out for sharp points or vertical tangent lines. There is that like connection. That's good. Differentiability, continuity. But discontinuity, something is wrong. What's wrong? F of c, f of 1, and f of negative 1 does not exist. It fails the first condition of continuity. Anyway, that was a reminder. Horizontal asymptote. It's not a forever card, but it's important. Horizontal asymptote.
What's the degrees?
Two ways of thinking about it. Degree test, that's the pre-cal way of thinking about it. I'm also going to put in green, just because green, I don't know, I made it calculus in this case. I probably should switch the colors because green is more review, but it's all review. Degree test, or you could do limits to infinity. But the limits to infinity are the degree tests, right? At least that's our shortcut way of doing it. So in this one, if I was to take a limit to infinity, aka thinking about a degree test of 2x over x squared minus 1, and technically whether I go to positive or negative infinity, either way the bottom wins, and if the bottom wins, does anybody remember the degree test? It goes to 0, aka is there an HA? The answer is yes, at y equals 0. So what do I have so far? Okay, well I have this point 0, 0, and that's lame. Well, I got him twice, and it's only 1 point. I have some vertical asymptotes. I have no poles, so forget that. And then I have a horizontal asymptote. What's this next guy? OA.
Oh, shoot.
Origin.
Okay.
Oscillation.
Slanty or
Bleak.
oblique.
Got it.
Slanty or oblique asymptotes. If there is a horizontal asymptote, I'm getting closer and closer and closer to, will there also be a slanty asymptote? I'm getting closer and closer to the same time.
Perhaps.
No.
It's probable.
Okay, there is such a thing as a slanty, but if there's a slanty, there won't be a horizontal. If there's a horizontal, there won't be a slanty. You can't have two different things going on to infinity, at least not with rational functions. So,
Oh, because there's an horizontal plane.
nice thing is you can say none. If there's a horizontal, there will not be an oblique. But how do we find it if we need to?
I ate more. I'm sorry.
You guys would need to go back to your summer packet and review, but long story short, it's long division.
You okay there?
Yeah.
And it's long division only when the top wins, which the nice thing is, if the top wins, there's no HA. So that's kind of a quick reminder. The top wins by only 1 degree. So if this was flipped and I had an x squared minus 1 over 2x, then I would have oblique asymptotes and I have to go looking for it by long division, ignoring the remainder. You guys will probably see 1 or 2 in homework, but we'll look at those when you come to them. Symmetry. What do we got? Odd?
Yes.
Even?
Perhaps.
Or neither? Odd. You plug in a negative and it flips the whole thing. Opposite. Even. You plug in a negative and it all stays the same after you simplify. And neither, it's a mixture of same and opposite. If I plug in a negative to this guy, I would get y equals, if you want to look at it, f of, oh, that's way too
Wow.
awkward. Let's not do that. Bloop, 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 bloop.
What?
F of negative x, I plug in a negative, right? So it'd be negative 2x, negative x times 2. What's going to happen down here with negative x squared minus 1? And if the book were to write this, they would write this with a big old negative in front awkwardly all over. Because a negative here, a negative over a same is a negative. It basically did what? Made the whole thing
change.
opposite.
Sorry.
That, well, on the bottom it stayed the same, but on the top was a negative. So negative over same is a negative, like an opposite of the whole thing. I know. So this one?
You got 100 more locks though.
And domain, we already figured out. X can't equal any of our discontinuities. Do we have the pre-cal analysis? Yeah.
What did I do?
Are we okay?
No.
Shut up.
But have we done the pre-cal review?
Yes.
Hoorah.
Yes. So what can we do with this pre-cal review?
Wait, is that X plus minus 1?
Plus the
X is not equal to plus or minus 1.
Or minus.
So if we were trying to graph right now, we could go ahead and do a lot. We could go ahead and have our negative one, have our positive one. We could go ahead and show our vertical asymptote, show our horizontal asymptote. Oh, that's awkward. We have a point in the midst of our horizontal asymptote. Because vertical asymptotes, vertical asymptotes are you shall not pass. Vertical asymptotes you can't touch, you can't cross. It is getting closer and closer and closer. The horizontal asymptote just says eventually stabilizing. That's all horizontal asymptote means, is eventually somehow I'm stabilizing, closer, closer. Somehow I'm stabilizing, closer, closer, closer. But I can cross as many times in between if I want. Horizontal asymptote just means stabilizing. Vertical asymptotes, thou shalt not pass. There's like a Gandalf meme. Anyway, vertical asymptotes, no. Horizontal asymptotes, sure, just eventually stabilize. But do we know anything else? Did that, that's 1 and 2. Did that, that's 3 and 4. Did that, that's 5. Did, oh, there isn't none, 6. Odd, I don't know what he looks like. And then some of you could make guesses, but we're kind of stuck. Unless, in pre-cal, we would make a table of sufficiently many solution points. The awkward homework that everybody hated from chapter 2, where you just plot points and guess. Now, could we plot a lot of points and start guessing? Yes, but do you guys realize we'd have to do some fractions to get in here and to get in here? So let's do calculus, because we know more. We can talk about when it's increasing, when it's decreasing, if it has relative mins or maxes, if it has any concavity, by looking at the derivatives. Nice thing is, once again, do you have to find these by hand? No. You could do practice for your final, but you don't have to. Critical numbers. Which one do I use? Right? Critical numbers. Forever card. Critical numbers. If f exists, ooh, so not plus or minus 1. If f exists and the derivative equals 0 or dne. So don't I take my, right? F prime is set the top equal to 0, set the bottom equal to 0, which are the dne's. And I need to watch out for domain. Because remember, forever card says f must exist. If I set the bottom equal to 0, in this one, I get x equals plus or minus 1, but why am I going to put a slash through those? What's my domain say about plus or minus 1?
They do not exist.
F does not exist, so those are not critical numbers. Now, they're going to be in my increasing and decreasing sign chart, because I always put domain issues in my increasing and decreasing sign chart. Oops, positive one, sorry. I'm going to put them in my sign chart, but they are not technically critical numbers. That's rough. In increasing, decreasing, we look at the sign of f prime to help us with the behavior of f. Anyway, whoop, oh, okay. So set the top equal to 0. Easy. X equals plus or minus square root of negative 1. Why are we going to wave at him too?
Hi.
Those are imaginary. He's not going to show up on my graph. There are none?
No way.
Which means I don't have to put anything besides my vertical asymptotes in my sign chart. Now, how do I do a sign chart? Increasing, decreasing, I test the signs. You guys see how this is a grand old review of chapter 3?
Yeah.
All right. Plugging in -2. Plugging them in where? Here. Oh, that's always positive. That's always positive times a negative. Well, that's okay.
Decreasing.
Plugging in 0. Wait, positives, positives. That's a -2.
Decreasing.
Wait, everything. It's always positive and always, all of these are negatives? So it's going down, going down, going down.
Going down. Why isn't that decreasing in the end?
So he's only decreasing on, but why am I going to write the intervals, guys?
Because there's asymptotes.
Yeah, I have to separate and say you're not allowed to exist at 1 or -1. It's just a quick reminder. Okay, so my function is strictly decreasing. If he's strictly decreasing, are there any extrema?
No.
No. First or second derivative tests. I'm going to wait until you get back chapter 3A tests either. Probably not tomorrow, I'm getting in 2B. Probably Wednesday. To talk about these, but you would do one of the 2 tests for relative extrema. But if you look at this, none. Because do you guys see any sign changes?
No.
At any points that exist? No. No sign changes and definitely not any points that exist, so none. And there were no critical numbers. Critical numbers are the only candidates for relative extrema. So much forever crying knowledge in this one page. Pips! Where do I look?
The second.
Second derivative.
Because inflection points have to come from the second derivative. Ugh, some of you guys. Okay, so I need to set f double prime equal to 0 or dne. Ah, look, he's right there. We're going to set him equal to 0 or dne. And once again, we need to watch out for domain because can there be a point of inflection at a vertical asymptote?
Yes.
No. No.
Thou shalt not pass. You cannot be at a vertical
No.
asymptote. Domain problem. So if you ever say there's a point at a non-existent point, you just failed. So watch out for domain still, which is why actual inflection points, and technically even possible inflection points, start with f must exist, like critical numbers. So when I set the bottom equal to 0 and realize that's at x equals plus or minus 1, why am I crossing it out? Those are the domain problems. Those don't exist. So they cannot be possible inflection points. But why am I going to come up here and say, ooh, x equals 0?
Because 4x.
I need to set 4x equal to 0 and x squared plus 3. But wait a minute. I need to cross out that imaginary square root of a -3, right? Good. But do I have a pip?
Yep.
Yeah. At x equals 0. Oh, I have one of those guys. Concavity. I take that pip and I say I better plug him into, but why am I also putting in -1 and 1 to my second derivative sign chart?
Because you want to know everything.
Well, and I don't just put in pips. I always put in not just crits, but also domain problems. Not just pips, but also domain problems. Right? I'm going to make these red because, well, we don't always put in -1, 0, 1. Just in this problem, we put in -1, 0, 1. And the goal for concavity, now remember, concavity is the behavior of f. F prime is actually increasing, decreasing. But we test the signs of f double prime. So plugging in -2. Well, this guy's always positive. This guy cubed, oh, he can be negative. Okay, stink. Let's look here and here. If I plug in -2, that's a negative. If I plug in -2, 4 minus 1 is a positive. Negative over a positive is a negative, which means that guy's concave down. Plugging in -1/2. Negative? Oh, but -1/2 squared is a 4 minus 1. That's also a negative. Cubed is a negative. A negative over a negative is a positive. Huh. So wait a minute. This guy is decreasing and concave down, and has to get closer and closer and closer, decreasing and concave down. And the next one, he's decreasing and concave up. Has to get closer and closer, decreasing, concave up, going into the point. Now, plugging in 1/2. 1/2 is a positive, but that's still a negative. Maybe you would have guessed that. Uh-oh, so I'm really hoping the actual inflection point, I figure out 0, 0 is an actual inflection point, because I see an inflection point, don't you? I'm plugging in 2. Oh, that's all positive. Guys, I did it fast. But one little mistake in plugging in can mess the whole thing up. But do I have him decreasing, decreasing, decreasing? Yeah, just like. And do I have him concave down, concave up, concave down, concave up? 1 over x? Kinda, but not really. Points of inflection. Do I have one? Yes. I have 3! Look, no I don't. I don't have 3. Who's not allowed to be considered?
Oh,
right? These ones, now some people, or I've sometimes put little dotted lines to remind myself, like, no, doesn't exist. Don't look at them because there is a sign change, but you are not a point. There is a sign change, but you are not a point. But who is a point? Sign change at 0. And the point of inflection would be, hey, do we have our graph?
Yeah.
From doing 14 things and the graph is number 15? Yes. John, you cracked me up. So guess what? I know time is pretty much up for today, but can I show you what the rest of this is going to look like?
Doing that over and over and over.
Because we did, awkward. This guy got, yes.
No.
Because we have 14 things in a graph, yeah?
Yeah.
What are we going to do tomorrow?
Oh.
We already got that guy. Let's get rid of him. 14 things to somebody new. A 4th degree polynomial. How are we supposed to see a W? Is he a U? Is he a 4th degree polynomial? Do 14 things, and guess what we're allowed to do after that? A graph. And then, get rid of him. And then 14 things with a nasty square rooty guy. And guess what we're going to do after that?
So we just have homework tonight? Is what you're telling us?
So, do you have the general idea of all of this section? Yes. Could you go through and find all the derivatives to practice for your final and get them simplified? Sure. But could you just start using my derivatives and see if you can do the 14 things to get to your own graph? Yes. Guys, in your homework, I have videos from past years. If you want to look ahead to examples to get ahead in homework, that's totally fine. But otherwise, I'll see you guys later. Yeah.
After school.